In this part, we will discuss list, tuples, and sets. Introduction to list, functions for list, passing list to functions, operations on list, searching and sorting, multidimensional list, advanced list processing, sample programs on list, Lotto number and deck of cards programs, introduction to tuples, set creations and accessing sets, dictionary operations and methods. In part 1, we have already seen about the list. Now we will see more detail about the list structure. A list can store a collection of data of any size. A list is a sequence defined by the list class. It contains the methods for creating, manipulating, and processing lists. Elements in a list can be accessed through an index. Creating list. The list class define list. To create a list, you can use list constructor as shown below. List 1, this is the list. This can be created by using the list class. List 1 is equal to list, open and close the parenthesis. This code create an empty list. List 2 is equal to list of open parenthesis within square bracket data elements. For example, 2, 3, 4. It creates a list with elements 2, 3 and 4. List 3 equal to list of open parenthesis within square bracket within double quotes red, green, blue. It creates a list with strings. List 4, list of range of 3, 6. This code creates a list with elements 3 starting from 3, 4 and 5. Because start element is 3, end element is before 6, that is 5. List 5 equal to list of within double quotes open and close parenthesis A, B, C, D. So it creates a list with characters A, B, C and D. You can also create a list by using the following syntax, which is a little simpler. So list 1 is equal to within square bracket. So simple square bracket that indicates a list with empty elements. List 2 again within square brackets 2, 3, 4. It is used to create a list with elements 2, 3, 4 and so on. List is a sequence type. A string is a sequence of characters, while a list is a sequence of any elements. So we can perform lot of operations using a list. X in S is true if element X is in sequence S. X not in S, true if it is true if the element X is not in the sequence S. S1 plus S2, it concatenates two sequences S1 and S2. S is equal to S into N, N star S. This means N copies of sequences are concatenated. S of I, that is ith element in sequence S. S of I colon J, it's a slice of sequence S from index I to J minus 1. Len of S, length of sequence, that is the number of elements in the sequence S. Min of S, smallest element in sequence S. Max of S, largest element in sequence S. Sum of S, sum of all elements in sequence S. For loop, it traverses elements from left to right in a for loop. And comparison of any two sequences, we can use the comparison operators like that: less than or equal to, greater than or equal to and not equal to. Functions for list. Several Python built-in functions can be used with list. You can use the length function to return the number of elements in the list, the max-min functions to return the elements with the greatest and smallest values in the list, and the sum function that returns the sum of all elements in the list. You can also use the shuffle functions in the random module to shuffle the elements randomly in the list. So the next part that shows the examples of shuffle and random. First you have to create a list with 5 elements. List 1 equal to within square bracket 2, 3, 4, 1, 32. Length of list. So here 5 elements are there, so it will return 5. Max of list, the maximum element in the list is 32, so it will return 32. Min of S, that returns the minimum or smallest element in the list, that is 1. And sum of list, so it will sum all the element in the list. So 32 plus 1 plus 4 plus 3 plus 2 is 42. So next, if we want to create a random elements in a list and those elements that can be shuffled. So first you have to import the random. Import random. random dot shuffle of list 1. So shuffle the element in the list 1. Already list 1 consists 2, 3, 4, 1 and 32. Now these elements can be randomly shuffled. So you may get different answers at different time when you are running these programs. This time it will get 4, 1, 2, 32 and 3. Passing list to functions. When passing a list to a function, the contents of the list may change after the function call, since a list is a mutable object. Since list is an object, passing a list to a function is just like passing an object to a function. For example, the following function displays the elements in the list. Here the function name is printlist, def printlist lst. For elements in lst, print element. So you can involve it passing a list. So a list is passed inside as an object of the functions. For instance, the following statement invokes the print list function to display 3, 2, 1, 2, 6, 4 and 2. Print list of 3, 1, 2, 6, 4, 2. The preceding statement creates a list and passes it to the function. There is no explicit reference variable for the list. Such a list is called an anonymous list. This is the main program. Def main colon x is equal to 1. X is an variable which holds the integer value. Y is equal to 1, 2, 3. Y is also a list. Then m of x comma y. So you can invoke m with arguments x and y. Print x is x value. Print y of 0 is y of 0. Def m of number comma numbers. Number equal to 1001. Assign a new value to the number. Number of numbers of 0 equal to 555. Assign a new value to the numbers of 0. Now you can call the main functions. So it will display x is 1. Y of 0 is equal to 5555. Operations on list, searching and sorting. Searching list. There are two types of the searches are available in list, linear search and binary search. If a list is sorted, a binary search is more efficient than a linear search for finding an element in the list. Searching is the process of looking for a specific element in the list. For example, discovering whether a certain score is included in a list of scores or not. The list class provides the index method for searching and returning the index of the matching element from a list. It also supports the in and not in operators for determining whether an element is in a list or not. Searching is a common task in computer programming. Many algorithms are devoted to searching. Now we will discuss two commonly used approaches, linear search and binary search. Linear search approach. The function for finding a key in the list. So first we have to declare a function. So key def linear search. It takes two arguments. One is the list, second one is the key. For I in range length of list, if key is equivalent to list of I, return -1. So the ith position, the list, the key, compare key with list of I for I is equal to 0, 1, 2. So it takes the index from I of 0, I of 1, I of 2 and so on. LST is equal to 14425 minus 362. So J is equal to I is equal to linear search of LST comma 4. So it will returns 1 because the search key is 4. It will check whether the key 4 is in that list or not. It is in that list. So if the element which is going to be searched is in this list, it will returns 1. The element which is not in the list, it will return such as time it will return -1. And the next one, J is equal to linear search of list comma -4. -4 is not available in the given list, so it returns -1. K is equal to linear search of LST comma -3. -3 is also available in the list, so it will returns 5. The binary search approach. A binary search is the other common search approach for a list of values. For a binary search to work, the elements in the list must already be ordered, that is sorted. Assume that the list is a ascending order. A binary search first compares the key with the element in the middle of the list. Consider the following three cases. If the key is less than the list middle element, you need to continue to search for the key only in the first half of the list. If the key is equal to the list middle element, the search ends with the match. If the key is greater than the list middle element, you need to continue to search for the key only in the second half of the list. So this binary search algorithm, it can be used before the elements in the list are sorted, that is in that ordered way, ascending order way. First we have to divide the entire list into two parts based on the middle element, middle value. Then we have to take the key element which is going to be search whether it is present in that list or not. Then if that element is equivalent to the middle element, yes, the element, the search key is available in that list. If the element is less than the middle element, then you have to continue to search for the key only in the first half of the part. If the key element is greater than the list middle element, then you have to continue your search in the second half part of the list. The binary search eliminates half of the list from further consideration after each comparison. So key is 11. So first we have to divide the entire list into two equal parts. So for that we have to find the mid element. So now the mid element is, the mid index is 6. So the mid element in that index is 50. For example, the search key value is 11. So the 11 is less than the mid element 50. So the element must be in that first part. So we have to go search only for the first half. So the 11 is also presented in the key. So we have to suppose if the key is greater than 7, then we have to go only the, now the ordered elements are 2, 4, 7, 10, 11, 45. Now we want to check the element 7 whether it is in that list or not. So we have to go for the second half of the part, because if 7, the key value that is greater than 7, next key value is equal to 11. Like that we may go for searching in the binary search. This is the code, version 1 and version 2. The two types of the codes are given both in def binary search list comma key colon, low is equal to 0, high is equal to length of list minus 1, mid is equal to low plus high divided by 2. That we have to do it in low plus high, that we have to do it in version 1. If key, here we are using if only. The next program version 2, it uses the while loop. If key is less than a list of mid, high is equal to mid minus 1, if key is equal to list of mid, return mid, else low is equal to mid plus 1. The same code can be used with the help of while loop. While high is greater than or equal to low, mid is equal to low plus high. If key is less than list of mid, high is equal to mid minus 1, if key equal to list of mid, return mid, else low is equal to mid plus 1, return minus 1 if not found. Complete binary search program here. Use binary search to find the key element is in the list or not. Def binary search of list comma key, low equal to 0, high is equal to length of list minus 1, while high is greater than or equal to low, colon, mid is equal to low plus high. If key is less than list of mid, high is equal to mid minus 1, if key equal to list of mid, return mid, else low is equal to mid plus 1, return low minus 1. This is the sample program. Sorting list. There are many strategies for sorting elements in the list. Selection sort and insertion sorts are two common approaches. The list can provide the sort method for sorting a list. Many different algorithms have been developed for sorting. This section introduces two simple intuitive sorting algorithms, selection sort and insertion sort. Selection sort. Suppose that you want to sort a list in ascending order. A selection sort finds the smallest element in the list and swap it with the first element. It then finds the smallest element remaining and swaps it with the first element in the remaining list, and so on until only a single element remains. The following figure shows how to sort the list, which consists the elements 2, 9, 5, 4, 8, 1, 6 using a selection sort. So first the elements are in the shown in figure 1, 2, 9, 5, 4, 8, 1, 6. So select 1 because that is the smallest element in the list and swap it with the first element in the list. First element in the list is 2, so that can be swapped with the smallest element in the list. So 1 will come into the 2's place and 2 will go to the 1's place. Next, now number 1 is now in the correct positions. So next we will go for the next one. Ninth is the next element, and the smallest element, the remaining smallest element in the list is 2. So 9 is greater than 2. So we have to swap it. So 2 will come to the 9th place and 9 will go to the 2's place. Next element is 5, and the smallest element in the list is now 4. So 5 and 4 we have to check it, and 5 is greater than 4, so we have to swap it. So 4 will come to the 5's position and number 5 will go to the 4 positions. So now 1, 2, 4 are in sorted way. 1, 2, 4, 5 are in the sorted way, and the next we have to check 5, and the next smallest element is 6. 5 is obviously smaller than 6, so no need for swapping. And the next element is 8. 8, that will be checked with the remaining elements 6. So 8 is greater than 6, so now we have to swap it. So 6 will come to the 8th position, 8 will go to the 6th positions. Now the next element in the list is 9 and 8. 9 is greater than 8, so we have to swap the positions of 9 and 8. Now all the elements in the list are in ordered way. So this is the program for sorting the elements in ascending order. Def selection sort list for I in range length of list minus 1 colon. Find the minimum in the list of I colon length of list. Current minimum is equal to list of I. Current min index is equal to I. For j in range I plus j comma length of list colon, if current min is greater than list of j, current min is equal to list of j, current min index is equal to j. Swap list of I with list of current window x, current min index if necessary. If current min index is not equal to I, list of current min index is equal to list of I, list of I is equal to current min. To understand this function better, trace it with the following statements. The list of elements 1, 9, 4.5, 10.6, 5.7, minus 4.5, selection sort of list. Insertion sort. Suppose that you want to sort a list in ascending order. The insertion sort algorithm sorts a list of values by repeatedly inserting a new element into a sorted sublist until the whole list is sorted. The following figure shows how to sort the given elements using the insertion sort. Initially, the sorted sublist contains the first element in the list. Insert 9 into the sublist. The second step, the sorted sublist consists the elements 2, 9. Insert 5 into the sublist. The step 3, the sorted sublist consists 2, 5, 9. Insert 4 into the sublist. So now the sorted sublist is 2, 4, 5, 9. Insert 8 into the sublist. Step 5, the sorted sublist is 2, 4, 5, 8, 9. Insert 1 into the sublist. So now the sorted element is 1, 2, 4, 5, 8, 9. Insert 6 into the sublist. The entire list is now sorted. So this is the program for sorting the given elements using the insertion sort. Def insertion sort of list for I in range of 1, length of lst. Insert list of I onto the sorted sublist list of 0, 1, so that list of 0 colon I plus 1 is sorted. Current element is equal to list of I. K is equal to I minus 1 while k is greater than or equal to 0, and list of k is less than current element colon. List of k plus 1 is equal to list of k. K is equal to k minus 1. Insert the current element into the list k of list of k plus 1. List of k plus 1 is equal to current element. To better understand this function, trace it with the following sentence. List is equal to 1, 4, 9, 4.5, 10.6, 5.7, minus 4.5 insertion sort. Multi-dimensional list. Data in a table or a matrix can be stored in a two-dimensional list. Processing two-dimensional list. A value in a two-dimensional list can be accessed through a row and column in the column index. The rows can be accessed using the index conveniently called a row index. The values in each row can be accessed through another index called a column index. A two-dimensional list named matrix is illustrated in figure. So matrix, it consists sum of the elements, it consists rows and column. So each and every element in the list is accessed based on its row index and column index. So matrix of 0, 0 is first. The element presented in this index is 1. Matrix of 4, 4, that is the index row index is 4 and the column index is 4, that consists the element 3. This is the example for the two-dimensional list which can be accessed with the help of the row index and column index. Each value in matrix can be accessed using matrix of I, J, where I and J are the row and column indexes. Initializing list with input values, matrix is equal to square bracket, that is used to create an empty list. Number of rows is equal to E value, input, enter the number of rows. Number of columns is equal to E value, input, enter the number of columns. For row in range, number of rows, matrix dot append, add an empty new row. For column in range, number of columns, value is equal to eval, input, enter an element and press enter. Matrix row dot append of value, print matrix. Initializing list with random values. The following loop initializes a list and that shows random values between 0 and 99. Input random, matrix of empty square bracket. So it creates an empty list. Number of rows is equal to eval, input, enter the number of rows. Number of columns is equal to eval, input, enter the number of columns. For row in range, number of rows, matrix dot append, add an empty new row. For column in range, number of columns, matrix row dot append random dot rand int of 0, 99, print of matrix. Printing list. Matrix is equal to list of elements. Assume a list with some elements. For row in range, length of matrix. For column in range, length of matrix row. Print matrix of row and column, end. Print the only a print statement, it will print the new line. Otherwise you can write matrix of, assume some list of elements. For row in matrix, for value in row, print of value, end, print. Summing all elements, use a variable named total to store the sum. Initially total is 0. Add each element in the list to total by using a loop like this. Matrix of, assume a list of elements, total is equal to 0. For now, for row in matrix, for value in row, total is equal to total plus value, print total. Summing elements by column. For each column, using a variable named total to store its sum, and add each element in the column to total using a loop like this. Matrix of, assign some given element of elements. For column in range, length of matrix of 0, total is equal to 0. For row in range, length of matrix, total is equal to total plus matrix of row column, print sum for column, column is total. Finding the row with the largest sum. To find the row with the largest sum, you may use the variables max row and index of max row to track the largest sum and the index of the row. For each row, complete its sum and update max row and index of max row if the new sum is greater. Matrix here equal to, within square bracket, you can assign the list of elements. Max row is equal to sum of matrix of 0 gets sum of the first row in max row. Index of max row is equal to 0. For row in range 1, length of matrix, if sum of matrix of row is greater than max row is equal to sum of matrix of row. Index of max row is equal to row, print row. Index of max row has the maximum number of sum of max rows. Random shuffling. You can shuffle the elements in a one-dimensional list by using the random.shuffle of list functions. How do you shuffle all the elements in a two-dimensional list? To accomplish this, for each element, matrix of row, column, randomly generate indexes I and j and swap matrix row and column with matrix ij as follows. Input random matrix, assume a list of elements. For row in range of length of matrix, for column in range length of matrix of row, I is equal to random int 0, length of matrix minus 1. J is equal to random int 0, length of matrix row minus 1. Swap matrix row column with matrix ij. Matrix ij, matrix row column. Print matrix. Sorting. You can apply the sort method to sort a two-dimensional list. It sorts the rows on their first elements. For the rows with the same first element, they are sorted on the second element. If the first element and second elements in the rows are the same, their third elements are sorted and so on. For example, print of 42, 17, 45, 12, 11, 41. Prints dot sort, print out points, that is points is equal to something, point uh, print of points displays, so it will sort the elements 1 1 1 2, so it takes the first element and sort it, first element and second element and so on, 1 comma 7, then 4 comma 1, 4 comma 2, 4 comma 5. Case study, lotto numbers and card decks. Lotto number, this is the problem. Each ticket for the pick 10 lotto has 10 unique numbers ranging from 1 to 99. Suppose you buy a lot of tickets and like to have them cover all the numbers from 1 to 99, write a program that reads the ticket numbers from a file and determines whether all numbers are covered. Assume the last number in the file is 0. Suppose the file contains the elements. Yep, so it consists the numbers from 0 to 99. So your program should display the tickets cover all the numbers. Suppose the file contains only a very few numbers between 0 to 99, then your program should display the tickets don't cover all numbers. So how do you mark a numbers as covered? You can create a list with 99 boolean elements. Each element in the list can be used to mark whether the number is covered. Let the list be is covered. Initially, each element is false. Whenever a number is read, its corresponding element is set to true. Suppose the numbers entered are 1, 2, 3, 99 and 0. When number 1 is read, it is covered is set to true. When number 2 is read, it is covered 2 of minus 1 is set to true. The algorithm for the program can be described as follows. For each number k, read from the file, mark number k as covered by setting is covered of k minus 1 true is covered. So it consists the values 0, initially 0 to 99 or 0 to 98 all are false. Then first number 0, it is by default it is false. When it is checked, then it is true. Like that, each and every element it changes its states from false to true when it is read until all the elements are true when it is read. If every is covered of I is true, the tickets cover all numbers, else the tickets don't cover all the elements. This is the program and this is the sample output. And another case study is deck of cards. The problem is to write a program that picks 4 cards randomly from a deck of 52 cards. All the cards can be represented using a list named deck filled with initial values 0 to 51 as follows. Deck is equal to x for x in range of 52, or you can use deck is equal to list of range of 52. Card numbers 0 to 12, 13 to 25, 26 to 38 and 39 to 51 represents 13 spades, 13 hearts, 13 diamonds and 13 clubs respectively as shown in the following figure. Card number then double slash 13 determines the suit of the card and the card number percentage 13 determines the rank of the card, that is also shown in the following diagram. After shuffling the deck, pick the first 4 cards from the deck. The program displays the cards from these 4 card numbers. So 0 to 12, it is 13 spade cards, and 13 to 25, 13 heart cards, 26 to 38, that shows the 13 diamond cards, and 39 to 51, that is the 13 clubs cards. So when you randomly shuffled all the elements, the card number, for example, after shuffling, random shuffling, card number 6 is the 7. So 6 percentage 3. So it will return the remainder 6 of spades. So the remainder 6, 7 and 6 that falls in the first, that is 7, 13 is 0. Card number 48 is the 10. So 48 percentage 13 equal to 9 of clubs. So 48 by 13 is in 3. Card number 11 is the queen, 11 percentage 13. So 11 of spades, that is 0. Card number 24 is the queen, 24 percentage 13 is equal to 11 of hearts, 24 double slash 13 is 1. So this is the program. Create a deck of cards. Deck is equal to x for x in range of 52. Create suits and rank list. Suits is equal to spade, hearts, diamonds, clubs. Rank is equal to ace, 2, 3, 4, 5, 6 and so on something. And shuffle the cards. So you have to import the random function. Random.shuffle of deck. Display the first 4 cards for I in range of 4. Suits of deck of I double slash 13. Rank is equal to ranks of deck of I percentage 13. Print card number deck of I is the rank of suit. So you will get the when you run this program, you will get a 4 random cards. When you again run, you will get a different deck of cards. Tuples are like lists, but their elements are fixed. That is, once a tuple is created, you cannot add new elements. You cannot add new element, you cannot delete elements, you cannot replace elements or reorder the elements in the tuples because it is a fixed one. A tuple is very much like a list except that its elements are fixed. Furthermore, tuples are more effective than lists due to Python's implementations. You can create a tuple by enclosing its elements inside a pair of parentheses. The elements are separated by commas. You can create an empty tuple and create a tuple from a list as shown in below. T1 is equal to open and close the parenthesis, create an empty tuple. T2 is equal to open and close the parenthesis within 1, 3, 5, create a tuple with 3 elements that are 1, 3 and 5. Create a tuple from the list. T3 is equal to tuple of open parenthesis within square bracket 2 star x for x in range of 1, 5. You can also create a tuple from a string. Each character in the string becomes an element in the tuple. For example, create a tuple from a string. T4 is equal to tuple of ABC. That is, T4 consists the ABC, ABAC. Sets are like lists in that you use them for sorting a collection of elements. Unlike lists, however, the elements in the sets are non-duplicates and are not placed in any particular order. Creating sets. You can create a sets of elements by enclosing the elements inside a pair of curly braces. The elements are separated by comma. You can create an empty set or you can create a set from the list or a tuple as shown in the following examples. Set is equal to set of S1 is equal to set, create an empty set. So S2 is equal to 1, 3, 5, create and set with 3 elements. S3 equal to set of 1, 3, 5, create a set from a tuple. Create a set from a list. S4 equal to set of x star 2 for x in range 1, 10. Likewise, you can create a list or tuple from a set by using the syntax list of set or tuple of set. You can also create a set from a string. Each character in the string becomes an element in the set. For example, create a set from a string. S5 is equal to set of ABAC. S is ABC. Manipulating and accessing sets. You can add an element to a set or remove an element by using an add of E or remove of E method. You can use the length, min, max and sum functions on a set and for loop to traverse all elements in the set. For example, you can use the in or not in operator to determine whether an element is in the set or not. S1 is equal to set of elements 1, 2, 4. S1 dot add of 6. So 6 will be added. Length of, after adding, the length will be 4. Maximum of element in the set, max of S1 is equal to 6 now. Subset and superset. A set S1 is a subset of S2 if every element in S1 is also in S2. You can use the S1 dot is subset of S2 method to determine whether S1 is a subset of S2 as shown in the figure. So S1 1, 2, 4, S2 is equal to 1, 4, 5, 2, 6. S1 is a subset of S2. Whether it is a subset, then it will return true. Yeah, set S1 is a superset of S2. If every element in S2 is also in S1, you can use the S1 dot is superset of S2 method to determine whether S1 is superset of S2 as shown in the following code. S1 is equal to 1, 2, 4, S2 is equal to 1, 4, 5, 2, 6. S2 dot is superset of S1. S2 is a superset of S1, then it will return true. Equality test. You can use the double equal to and not equal to operators to test if two sets contains the same elements. S1 is equal to 124, S2 is equal to 142. So S1 is equal to double equal to symbol is used to test whether both are similar. If it is same, then it returns true. S1 is not equal to S2, then it returns false. In this example, S1 and S2 contains the same elements regardless of the order of the elements in the set. Note that it makes no sense to compare the sets using the conventional comparison operators less than, greater than, less than or equal to, greater than, equal to, but the elements in a set are not ordered. However, these operators have special meanings when used for sets. S1 less than S2 returns true if S1 is a proper subset of S2. S1 is less than or equal to S2 returns true if S1 is a subset of S2. S1 greater than S2 returns true if S1 is a proper subset of S2. S1 greater than or equal to S2 returns true if S1 is a superset of S2. Dictionaries. A dictionary is a container object that stores a collection of key value pairs. It enables fast retrieval, deletion and updating of the value by using the key. So dictionary consists the key value pair. Search key is there and its equivalent value is also there. For example, if you want to store the students' name and register numbers or their IDs and mail ID, we can use the dictionaries. So you can create a dictionary by enclosing the items inside a pair of curly braces. Each item consists a key followed by a colon followed by a value. The items are separated by commas. For example, students is equal to curly braces, some ID colon, name, the John, comma, and so on. Creates a dictionary with two items. You can create an empty dictionary by using the following sentence. Students is equal to empty curly braces. Python uses curly braces for sets and dictionaries. The syntax curly braces denotes an empty dictionary to create an empty set. Adding, modifying and retrieving values. To add an item to a dictionary, use the syntax dictionary name of key is equal to value. For example, students of some ID register number equal to student's name. If the key is already in the dictionary, the preceding statement replaces the value for the key. To retrieve a value, simply write an expression using dictionary name key. If the key is in the dictionary, the value for the key is returned. Otherwise, a key error exception is raised. This is the sample program. Deleting items. To delete an item from a dictionary, use the syntax del dictionary name of key. For example, del students of that. So this student deletes an item with the key that numbers from the dictionary. If the key is not in the dictionary, a key error exception is raised. Looping items. You can use a loop to traverse all keys in the dictionary. For example, students list are there. For key in students, print key plus string students key. So it will traverse, displays all the students numbers and names. The len function. You can find the number of items in a dictionary by using the len of dictionary functions. So it will return the number of dictionary items. For in this example, 2 dictionary items are there. Testing whether a key is in a dictionary. You can use the in or not in operator to determine whether a key is in the dictionary or not. So you can use in not in function. If it is in is true, then it will return true. If it is not in that dictionary, it will return false. Equality test. You can use the double equal to not equal to operator to test whether the two dictionaries contains the same value or not. If both the dictionary items consist the same value, it returns true, otherwise it is false. The dictionary methods. Keys colon tuple returns a sequence of keys. Values colon tuple returns a sequence of values. Items colon tuple returns a sequence of tuples. Each tuple is key value for an item. Clear colon none deletes all entries. Get key of colon value returns the value of the key. Pop key of value removes the items from the key and returns its value. Pop item colon tuple returns randomly selected key value pair as a tuple and removes the selected items. This is the sample program.